Hello, Marquita. This is class for Wednesday, the 17th of October. What we're going to do um, is take a look at a couple of things. Your discussion this week and assignment um, are to work with surveys and the misleading ways that we can provide information. I'm going to send you an email later on with some attachments, including a set of definitions. I want you to ignore the chapter name on those definitions. It's out of an old class. But I'd like you to keep these saved for your use later on in the class. It will help you with understanding some of the terms we discussed on Monday. I will also have another set of handouts for you as well, because I think it's critical that you understand some of the concepts that we're working on. And what I want to do is provide you with some of this material so that you can you can make use of it. So I will be forwarding some of that to you. Some of that will come across as PDFs. And some of you some of it will also be some of it will be Word documents. So I will want to do that for you. Those will come in later today. What I need you to do is get started on these assignments. I note that nothing's been turned in yet. And so what I would like to do is have you understand some more of this. In doing a survey, we talked about that. We have to a bunch of decisions need to be made, and one of those decisions is who's your audience. We talked about that on Monday. Who's the audience? Who is who are you going to survey? And that predicts the kinds of questions. I was talking about the questions about in a survey of statistics, students whose some issues of final exams in statistics classes, and that's going to be in here. Let's bring this up. So what I chose was a statistics class, final exam grades, in a math class, a statistics class. So you wanted to find the population. Obviously, the population does not include all students at the school, because many of those students will never take a statistics class, so they're not part of your cohort. So what you want to do is look at those whose programs of study require them to take statistics. But then you need to limit your population, if you're looking at final exam scores, further limit the population to those who have actually taken the class. Otherwise, you've got useless data. If somebody hasn't taken the class, they don't have a final exam score. So what we want to do is look very carefully at all of those kinds of issues. So then you also want to determine if you're looking at all sections. I mean, in a large school, there may be a number of different sections of the statistics class. So are you looking at all sections, or are you looking at at just one particular section or one particular instructor. Those, again, change who you are looking at. If you're looking at one specific instructor, perhaps to compare how lenient or how tough instructors are, then that's a different survey. But if you're just looking at what these final grades are, you want to have all sections. So what are your questions? Well, your first question, of course, is how do you get a list of the students? Well, obviously the students will be listed in the school's records, and you may or may not be able to get a listing of students who have completed a statistics class. That's something you would probably be working with your school to get that information. Remember, and to a great extent, some of that information is protected under FERPA laws. So what you want to do is be sure that you can get the information. Then there's a couple of things you can do. One is to pick your randomization method. You may want to just line up all the students in alphabetical order and do a systematic survey of every 5th or 6th student. That's a perfectly legitimate way to randomize it, or to get a random sampling. Or you may want to randomly order the students. That's okay too, if you can do that. But still you can do that. Or you can even do, we talked about randomization schemes and generating random numbers that you can use as a basis for determining who to choose. But you also have the cluster method, which is each class itself can be considered a cluster. And so you pick an appropriate number of those classes, those sections, and survey every student in the class. That's another method you can use. So there's lots of ways you can choose to do that. Now the questions you have to ask, those are critical. Your questions need to be as unbiased as you can make them. And by unbiased, that means you need to not imply what the answers are. Now, it's fairly straightforward if you're just asking what were your final exams, exam scores in a class, especially if you make sure that it's anonymous so that people are not people are more incentivized to tell the truth about their scores rather than exaggerate them. So what you would want to do is first off confirm that they had finished the class. That's a housekeeping sort of thing. You may want to gather other data. If you're interested in doing what we call stratification, looking at the year in which a course was taken, you may want to compare final exam scores across years, gender, or any other way of stratifying, whether they took them, in their, most statistics courses are going to be 3rd or 4th year courses, so whether they took them in their 3rd or 4th year. All these things are possible ways that you can stratify your analysis by looking at different parameters. So what you want to do is think about how you're going to question. Now, the obvious, what was your score on your final exam, presumes that they know the score. They may not. And that is unfortunately the case. So you need to determine if they know what their score is. If they don't, then there's not much you can do except go on to the next. So you want to know what that score is. And that's So the question itself is pretty straightforward. If you were asking questions as an advertiser about services that are received, then you are going to have to ask different questions. We go back and look at the other one, which is the favorite product in a store. You may want to stratify your answers by men and women. That's one obvious different way to stratify things. You may want to look at what's the favorite product of retirees versus 30-somethings. So again, you're going to be doing that. Anytime you add stratification to your analytic technique, then you increase the number of samples, the number of participants in the study. Your sample size has to go up because you need to have sufficient data through all the strata that you're looking at. So again, questions are critical. Also, you need to ask questions that your answers are meaningful. The one rule about doing surveys is first off, you need to know what question you're gonna answer, and it could be simple, such as, you know, a favorite movie, but it can be a lot more complex. And which roads have the worst traffic in, say, the Fort Collins area? The answer to that is going to vary depending on what roads people drive on and what part of the city they live in. So again, when you do that, you need to be careful that you have enough data that you can answer it. Now, in Fort Collins is a small enough city, I think most of us would say that College Avenue is probably the worst in Fort Collins. Some of us might say Harmony is awful, but you then have to go out and look at your questions to be sure that you understand the kinds of answers you're going to get. You know, a question like your favorite movie, that's not a big deal. You're going to get a singular answer from each person, unless you get some waffler who says, well, that depends on whether you're talking about, you know, comedies or science fiction or whatever. And so you have to be, you know, when you're asking your questions, you need to be prepared for some significant variations in answers depending on the kinds of questions that you get. Again, a question is, what was your final score on your statistics final exam? You're going to get a number. And it might be a percentage or it might be a number of points. Who knows? But you're going to get a number. You have to look at those questions and ask a question in a way that doesn't, as I say, imply the answer. A question that we mentioned was, you know, do you prefer Coke or Pepsi? Well, there's three answers: Coke, Pepsi, or neither. Okay, so you're prepared for that. But if you ask a question like, what is your favorite soft drink? Then you're going to get a range, and it will depend on where in the US or where in the world people live, because there's regional soft drinks as well as the big national brands that we see on television. And the regional drinks are often much more, are often very popular in a small area. So again, be sure that you understand the questions that you're asking. Other things, I remember a survey that I heard about was a company was trying to start their own coffee shop. A couple of guys were starting their own coffee shop. And so what they did was they did a survey of the principal competition, which we all know is Starbucks. That's the principal competition to any local coffee shop, at least to getting it off the ground, because it's the most common. I mean, you've got 3 in a block sometimes. So you have, you go out, you talk, the survey was asking questions like, do you think Starbucks coffee is too bitter? And a lot of people do. But the question is, what is too bitter? And too bitter to me might be just right up your alley, might be exactly what you want. And the other question is, even if you think they're bitter, a lot of people then will add sugar and half or all these stupid flavors, which shows my bias. But they'll ask all these, they'll do things to make it more palatable. So a good question might be, do you drink your Starbucks coffee black? Or do you put sugar in it? Do you put milk in it? Do you put flavors in it? Do you like these sugary, desserty frappalappuccinos or whatever they are that people drink? And the question then is, so the just asking if you think it's too bitter, you're going to get a yes or a no answer. That might be exactly what you are trying to do, but it doesn't give you a whole lot of information. Would you prefer a coffee that is not as strong and not as bitter as often as Starbucks can be? And so again, you get then some answers. So another approach is to look very carefully at the question you're trying to answer. The other part to this survey was if you had an option locally that had less bitter coffees, milder roasts rather than strong roasts, would you patronize that as a coffee shop? Well, the answer to that is something that you might need in order to work out whether or not it was worth having a new coffee shop. So again, we have to work on that. So the issue of how we go about presenting data is then you have to find out how you're going to present the data. It may be that all you want to know is just exactly that, and you get what's your favorite movie, so you get a list. And how you present your data is a little different. So hold on a minute. Okay, so here is from a different book, not the one that you have currently for this class, but here's some slides I'd like to show you about presentation of data. There's lots of ways of doing this, and we're going to look at bad graphs too. But frequency distributions, histograms, statistical graphics, and so forth. Let's first off look at We'll do it this way. Let's look at some ideas here, and look at some characteristics of data. This is a just some data about some parameter, possibly wind direction. This is frequency data. Okay, so one of the things is a term called center. And this will be one of the attachments I send to you later. A thing called center, which is sort of and sort of an average value, indicating where the middle of a data set is located. And then variation is another measure. It's the amount that the data values vary, in other words, differ from each other. Distribution is the shape of the spread of data over a range, and we'll talk about bell-shaped curves later. And outliers are samples that lie very, very far away from the vast majority of others, and we'll see how that is represented as well. And then we look at sometimes the changing characteristics of data over time, and take a look at this, and we have in general, other than this third quarter, whatever this east number is way out of line with the others. Okay, so we're going to talk about frequency distribution now, or a frequency table. So it shows how the data set is shown across several categories by listing those along with the number of data values in each. And I'm going to give you an example here. So the pulse rates of males and females, and we have 40 samples of each in this table. You can see here where we've got females and males, and we've got this range. These are just in the order in which the data were obtained. And you can see that they range here for females. They range from a low of, as I see it, 60 pulse beats per minute to a high of 124 beats per minute. Okay, that's a pretty wide range. That's the range. So 60 to 144 or 124. So the range here is 64 across here. We go down here to the males, we get a slightly different set of numbers. We've got a low of 56 and a high of, looks like 96. So we have a range now of 40. So it's a narrower range. So the data have been stratified by female and male because we have different data. So here is a pulse rate, and this is for the females. This is what we call a frequency distribution. All we do is pick range. In this case, anything in the 60s, the 70s, the 80s, etc. And then we just list the number of times something appears that is between 60 and 69. So if we go back to the previous table, let's go back up. So we're looking at, we've got 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values in the range of 60 to 69. So that is on here as a 12. If we go back and do the same thing, we'll see that there are 14 values that vary between 70 and 79. We don't care what those values are because we've set our class as a class of those with a pulse rate between 60 and 69, 70 and 79. Class sizes need to be consistent. So we can't have 60 to 75, 75 to 100, etc. That is not useful. So we want to look at that. So this can now be presented in a number of ways. So the class limits are the smallest numbers that can belong to a class, the lower class limit. So that in this case is the 60, 69. The upper class limits are the largest numbers that can belong. Let's go back up. Sorry, that was a little. Okay, so that's the largest. But what are the class boundaries? They're the numbers that are used to separate the classes. In this particular case, it's going to be midway between the upper range of one class and the lower range of another. So the implied here is that we could have another class that's 50 to 59. So the class boundary here is 59 and a half. We're not going to have a half beat a minute as a pulse. So these are discrete data. Remember that definition from class, countable numbers. So 69, etc. So it's halfway between. The midpoints are basically add up the lower and upper range and divide by 2. So 60 plus 69 is 129. Divide that by 2 is 64 and a half, etc. The width is basically the class width is the number of the difference between two consecutive lower class limits or two consecutive lower class boundaries. So we've got 60 to 70, 70 to 80, etc. The reason for using these is we can look at large data sets, and we can look at the nature of the data, and we have a basis now for constructing our graphs. So our first thing is to determine the number of classes. And as a general rule, it shouldn't be less than 5 or more than 20. So we calculate the class width, which is the maximum of each value, the maximum value of the entire data set minus the minimum, in other words, the range of the data set, and divided by the number of classes, approximately. And we get a number. We want to round it up to a whole number. Then we choose a starting point, a minimum data value, or a convenient value below it as the first lower class limit. If we go back up to that, the data there, our lowest value for women was 60. Our lowest value for men, let me see if I think I have this data here. Hold on. Okay. Yeah. Yeah. All right. So our lowest value for the women was 60. The lowest value for the men was 56. So if we're going to put our class boundaries as 50 to 60, 60 to 70, so our first class boundary for the men would be 50 to 60. The last class would be 90 to 100 because the highest value for men was 96. So we do that as a way of choosing our lower limit. So, and then just list out the other class limits. Okay. Okay, so just add up, then you can do whatever you like to add up the number of entries. What you want to do is look and make sure that the total number of entries in that frequency distribution, in that column of numbers in each class, adds up to the total number of values in your data set. Relative frequency and percentage of frequency are two methods we use to calculate how many people, units that are in a class. So here, for the women again, we had 12 appearances in the 60 to 69. So the total frequency is 40. So the frequency, the relative frequency is 12 out of 40, which reduces down to 3 out of 10. Divide each of those by 4. Remember that from algebra. Divide each of those. So we get 3 out of 10. 3/10 is 30%. Okay. So we have a relative frequency of 30%. So what that tells us is that 30% of the sample at 40 numbers appear in that range, 35 in the next, and then we can look down and see what the relative frequency is here. We see the preponderance of the data. In fact, 92.5% of the data are between 60 and 89. So this tells us something about the distribution of the data. So then we have cumulative frequency. So what we do is we just go down the table and we add up each number. So 12 is by itself. So there's 12 at less than 70. And then less than 80, we add 12 and 14 to get 26. So what we're seeing is, again, by the time we get down to less than 90, 37 out of our 40 are there, okay? And we see here that, again, there's nothing in the 110 group, so, or nothing in the 120 group, 110 to 119. So this number doesn't change. Okay, so we look at these and we get all of this. What's the purpose of this? Is really to take a look at where the preponderance of the data lie. We're not going to get into to bell-shaped curves. You've seen bell-shaped curves a lot, I'm sure. We won't get there yet. And they're to a normal distribution. We'll get into that later on. Gaps in the data can be can show gaps in the data can show that we have 2 or more different populations. Gaps in the data here, the men's data does not go above 96, and yet we have the women with a couple above that level, 104 and 124. So there are gaps in there in that data. There are also so we that could tell us we have 2 or more populations. However, you can't say that because you will have gaps in the data if you have 2 or more populations. Okay. So we've discussed these things. Let's look at a visual tool called a histogram next. It's a set of bars of equal width drawn without gaps. Horizontal scale represents the classes of the quantitative data value, and the vertical scale is the frequencies. So here, this is a histogram of the data. And again, it shows visually what we saw from the frequency table, that the majority of our data are in these first 3 classes. Note that the lower boundary is the halfway between the lowest value of of one class and the highest value of another. Here we've got the 60 to 69 and 70 to 79. So the boundary between these is 69 and a half, halfway between. So what we're now seeing is visually a much clearer and obvious skewing of the data. Okay. And we can look at a relative frequency, looks the same because it's based on the same data. Okay, we have, if we have a really large data set, it is not unusual for the normal, the histogram to look like a bell shape. The frequencies start low relatively, increase to a maximum, decrease, and they're roughly symmetric. So here's one, excuse me, where we are looking at something. These look to be kind of interesting numbers. So what we've got is these values. So we have 10, 64. These are frequencies. 178. So we're here. This is the total frequency. These are this is frequency numbers. It's irrelevant what the data are, but this is what we call pretty much a normal curve. It may be a little skewed, but it's not particularly so. It goes from a low value and it rises to somewhere in about the middle of the data set, a high value, a maximum, and then, come on, don't do that. And then back down to a low value again. Are they the same? No, they don't have to be. Okay. Let's look at some other look at graphing. We have a frequency polygon. And that is simply, you just construct points, you just place points at the midpoint of the range. Okay, remember, this is the midpoint of the range 60 to 69, the midpoint of the range 70 to 79. 0 is just an arbitrary frequency of nothing. There's none there. And the same with going up past, you go one past the frequency, one past the last class. So this would be 134.5 over here, just telling us there's no data out here. And our first data point here is 12, 14, 13, okay, etc. And then we got 3 more. So we got 12, and 14 is 26, and 11, rather not 13. 11 is 37, 1 is 38, 1 more is 39, none keeps us at 39, and 1 more is 40. So again, these frequency numbers add up to the total number of data points. We can put these we can stratify the data. We can show differences in the data using a different method here, which is to put both of them on the same graph with different colors. And this makes the difference between the two groups real obvious, because what we have got here is none of the women had pulses below 60, but 15% of the men did. Okay, we have this plot, this is pronounced ogive, is just the cumulative frequencies. Okay, so remember, 0 frequency, this is for women, 0 frequency at the boundary below 60 to 69, and then 12, and then this is cumulative. So now we have 12 plus 14 is 26, and then plus another 11 is 37. So all we're doing is adding things up. Note that this part is parallel to the x-axis, so there is no there's no difference. We also have something called a dot plot. A dot plot is another way of looking at the data, except that here we are looking at putting a dot for every numerical value. So remember, if you go back to that table of data for the women, if you put that into spreadsheet form and then simply sorted by numerical order, that data field, what you would get is you would find out that you had 3 values of 60, 4 values of 64. So we place a dot at 60, and then for the next dot and the next dot. So 3 of those. Same here. And this gives a somewhat different picture of that distribution. What we're seeing is that the most common value, 1, 2, 3, 4, 5, 6, 7, 8, is a pulse rate of 72 for women. This is also known as the mode, which is another measure of center, the most common value. Excuse me. So we put a dot for every one. Excuse me. So here we see a better view of data that are way out of our range. This 124 is way out beyond the majority of the other numbers. These two are out beyond that as well. So we can put this in something else called a stem and leaf plot. So we've got stems. In this case, what we do is we look at the first digit of the variable of the number. In this case, we've got 60, the 60 to 69, and what we've got, we simply list the number. We list the frequency of the second digit, or it can be the third or fourth, depending on the magnitude of the data set. But we had 3 at 60, so this is the 60s, the 70s, the 80s. We had 3 that were 60, so we put in 3 zeros, 4 that were 64, and 5 that were 68. So we simply put the number of 8s and 4s and zeros. In the 70s, we had 8 that were 72 and 6 that were 76. So we put down 8 2s and 6 6s. In the 80s, we had 6 that were 80 and 5 that were 88. So we put down 6 zeros and 5 8s. So again, you can see that this is since there are more digits here, it tells us that there were the largest number of values were in the 70s. And then this is the 96 and 104 and 124. Bar graphs are another way of looking at this. Here we're going to look at a different data set, which is the median income of males and females. Median is another term for center. The median is the number that is exactly in the middle of the data set. Okay, so here we're looking at median income, and they're stratified by decades: 1950, 1960, 1970, 1980, 1990, and 2000. This is done as what we call a point in time. So in this year, we're not looking at every single year. This is not the 1950s or the 1960s. This is in 1950. For some data sets, it makes more sense looking at trends to look at large spans of time. So here, the median income of males looks to be about $2,500 a year in 1950, but for females, it looks to be about $1,000 a year. It increases. It increases here to about $4,000 a year in 60, and 2,000 or 1,500 or so for females. And you can see that although although males and females both have had increases, we're seeing that the median salary for women is still roughly half or 60% or so of that of the men. What we call a Pareto chart are simply qualitative data. So this is really an example of a data set that is what percent, and qualitative data can be percentage, can be numbers that don't represent anything particular, that represent qualitative data. And that is things like zip codes are numbers, but they don't really represent. They do represent an area. So we know that the zip code 8053525 is in Fort Collins, but it doesn't tell us where. It doesn't tell us, and there's not a value. 80525 is not of less value than 80538, which is a Loveland zip code. So these are just numbers. So we're looking here at how people find jobs, and we find that over 60% get their jobs through networking in one form or another. The next most common is about 15% come from newspaper ads, about 10% come off the internet. Clearly, this is not necessarily today. About 8% look like in-person application, about 5% employment agency, and about 2% comes through school. So I don't know when this is or anything else, but nonetheless, that's there. We can also look at this by using pie charts. Pie charts are useful and in some ways more interpretable, but they can get a little more difficult to read. So again, we have the same data. Where do people get their, how do people find jobs? So we see here that, again, the vast majority, 60%, 61%, I figured, get it through networking. Then the next, so we look at this and we see that each of these is in descending order, going clockwise till we get to school, which is the smallest. Now, your pie chart is useful for a relatively small number of classes of data. And if you had too many and you had a whole lot of things that were very small percentages, it becomes difficult to interpret this area here where the percentages are small. We have a scatter plot. So what we have is, again, one of our XY axes here. And we're looking at the temperature, air temperature, versus chirps of I think, probably crickets here. Or it might be birds. So anyway, we're looking at the temperature. And we're looking at the relationship, excuse me, of temperature and chirps per minute. So we can see that the data vary. In general, the warmer it is, the more chirps. But down here, we have a point that's way below the lower, that's way below the temperature. And we've got so this temperature has more than a higher temperature or a lower temperature. So we've looked at this number of chirps. We've got more chirps at a lower temperature than we have at a higher temperature. And then it bounces back up because we expect that. Roughly the data set can be drawn as a line that goes through there. These 2 points skew the data, but they can't be ignored. Even if you are leaving out some of the data in drawing your plot, you need to include the data some way. Here we're looking at a time series graph. So the Dow Jones high, the high point of the Dow Jones in any one year. Okay, so we see here that in general from 1960 up to 2000, and this is 2005, it looks like 2000, a little bit farther, maybe 2007 here. But we see a recession in the early 2000s. And this is before the recession that occurred in 2008-9. So we see that this dipped down over these years. So each year has a number. So this tells us that over time, with a few hiccups, the Dow Jones has a history of rising. So one of the things, when do you use a graph and when do you not? So if we have a small data set, you're probably better off using a table, like a frequency table. The graph should be something that has makes the data, or the viewer, the person looking at it, should make the nature of the data look really good, obvious to the viewer, and it's like our pie chart or our Pareto chart that we saw earlier. Should look really, really good. Let's look back up. The pie chart, this is really visually obvious. So is this. And in fact, what we're seeing here is the difference between a pie chart and a Pareto is usually we have one color. And oops, that was a mistake. Sorry about that. All right, we'll get down here. All right. Okay. Here we have a pie chart, and now we have different colors. So we're able to focus quite easily on the size of the pieces of this pie based on the color that we're looking at. So these are fairly easy to look at in terms of color. So construct a graph not to distort. So we'll look at some examples of that. And don't get fancy with the design. So there's some other things here that don't some choices, slanted lines, dots, or cross hatching, because really they're hard for people to see comfortably. Don't use area or volume for data that are one-dimensional. In other words, drawings of dollar bills to represent budget amounts. He says never publish pie charts because they waste ink on non-data and they lack appropriate scale. That I would quibble with that some. Here's an example of something that you've probably seen: the Consumer Reports car reliability data for two fictional brands. the Firebrand or the Speedster. So we can see that we get a key. A full circle blue is really good, is superior. A half circle blue is okay. A colorless circle is sort of neutral, and then we start getting into the bad. So we can immediately look at this and look at this, the Firebrand. This is the manufacturing year. We can see that the Firebrand consistently between 2000 and 2003 had far better engine repair rates than the Speedster. But we can also look here, and the Speedster has actually been improving. We look at transmission repairs. Speedster, Firebrand looks a little better. Electrical repairs, well, it looks like the Speedster consistently had good or excellent, but the later models of Firebrand are all superior. The suspension, however, in the Speedster looks in the later years to be superior to that in the Firebrand. So we can actually look at this and see differences between the cars. Well, let's look at some bad graphs here, all right? This is an example of using what we call a non-zero axis, all right? So let's look at something that was going on in a case that was available that happened a number of years ago. I think this is the case of Terri Schiavo, in which family in which she had no brain activity, and the family, some of the family wanted her feeding tube removed, and others fought it. And the courts made whatever their decision is. We won't look at that. So here we have two different ways of looking at the same data. 62%. So in the survey result by party, Democrats, Republicans, or Independents. So we have 62% of Democrats agreed with the court's decision, whatever it was. 54% of Republicans and 54% of Independents. But if you look at these two graphs, they're both presenting the same information, but this looks like an incredible increase in the number of Democrats. Like Democrats far in excess of Republicans or Independents agreed. But if we look at this, our scale starts at 53% and only goes up to 63. Whereas if you go on a scale of 0 to 100, now we're seeing that the difference here isn't all that great. So the issue is how you present the data. This skews the visual look. If you just looked at it and didn't pay attention to the score, you would see, oh my God, the Democrats are out of touch, or the Democrats had it right and everybody else had it wrong, depending on your issue. Here's another look here at income level based on education levels, and using this dollar bill two-dimensional thing to represent a difference. The problem is we're stratifying the data. Remember we said that classes should have the same width. They're not the same width. We've got, obviously, it's very difficult to determine what the same width. The bars have them, but the numbers here may not be. So we're looking at a very busy graph that doesn't tell us anything. If we're looking at it and reading it, we're going to think, okay, get an advanced degree, and is this an annual income average? Is it a median? What is it? We don't know. Here's another one, a way of looking at that by using cubes or solids. These boxes here, if we look at this and measure it, this box is 1/4 of the width of this other box. Okay. The actual income is only a fourfold difference. It's a significant number for most of us, but it's a fourfold difference. But this box is 4 times 4 times 4, which is 64 times the size of this. So the implication here, if you just look at it and didn't read the numbers, are that you're going to have a huge increase in income. So that's a very bad depiction. If we look at it now on a scale starting at 0 and going up to above the highest number, and here we'll just, and again, this is going to be, they haven't depicted it, but it obviously is some sort of average. Whether it's a median or a mean, we don't know. Mean is what we call the average. So here now we're seeing something that is a little easier. Yes, there's a significant difference, but not as much as that. So that's what I wanted to say about those things for now. Let's escape out of this. And let's do a new share. I don't want that. Okay, I want that. Oh yeah, I do want that. Okay, so let's go back to here. Go back to the discussion. So I need you to do the discussion, and then let's go take a look again at the assignment. You need to be working on that. So that's why I wanted to talk about misleading graphs. So I want you to remember we looked at these two, and you need to work on that assignment and submit it. So that's what you need. And okay, so that's it. So what I want you to do is send me an email with the word Lugano, Lugano, in the email that lets me know that you've listened to this. That'll get you attendance for today. So I'm going to go ahead and cut this off right now, and we'll see you on Monday. You can always email me if you need to. So I hope things are going well, and I'll see you Monday morning.